So in this video we look at the first derivative test for finding local maxima and local minima of a function f of x. And this test is basically just putting together everything that we've done at this point. We already know, for example, how to find critical numbers. Okay. We're already familiar with the idea that when the derivative is positive, then this implies that the function is increasing. And when the derivative is negative, that this will imply that the function is decreasing. Okay? We're already familiar with a sign line. We've done sign lines of both the function and the derivative. So we've done sign lines where you put f prime here, put your critical numbers of the function f, critical numbers of f on this sign line, and then put, fill in the signs for the derivative on those intervals. We've also done the sign line for f double prime, and we put the critical numbers of f prime on this sign line and filled them out. Okay, and we know that this sign line for f double prime tells you when the derivative is increasing or decreasing. Okay, so what we can say here is that this positive sign, the sign line for f prime, says that f is increasing, and this negative sign here says that f prime is decreasing on that interval. Okay. So this is where we've come from, and the first derivative test is a test to figure out if a function f of x has a local maximum or a local minimum. And so essentially what we're doing here is we'll draw the sign line for the picture that's shown. Notice that there are two critical values. The book is calling them x1 and x2, right? And we can see that the function is increasing. The tangent lines are positive, so we know that for the values of x less than x1, the derivative is positive. Between x1 and x2 in this region, the tangent lines are sloping downward, so the derivative is negative. And bigger than x2, the derivative is positive. The tangent lines are positive, and so this is a sign line for f prime. And therefore what we can say is that the function is increasing, then the function switches to decreasing, and then the function switches to increasing again. And so what we know is that when the function switches from increasing to decreasing, that you need to have a local maximum of the function here. And when the function switches from decreasing to increasing, as shown in this picture, we're going to have a local minimum of the function. So that's the first derivative test is just basically interpreting the sign line to determine when a function has a local maximum or a local minimum. So just as by way of a quick example, okay, let's just see if we can find the local maxima and minimums of this function here. Now, if you were to compute a plot of this, as I have done on this picture, on this graph that we've created, it's kind of hard to tell if you graph this plot where the function has a maxima or minima. It's kind of, just by the nature of the axes, it's kind of hard to tell what's going on. Okay, but let's see what the calculus has to say about it. We'll try to use our calculus to refine this plot a little bit. Okay, so again, this plot is kind of hard to interpret. It's hard to for me to see where the maxima and minima are occurring, because this big tail of the function is kind of swamping out everything. So let's look at some calculus. We could find the critical numbers That's always the first step. So we look at the derivative, 6x squared minus 12x plus 6. Set that equal to 0. It looks like we can factor out a 6. Looks like I'm hoping that this will factor the rest of the way, 6x minus 1 squared. Okay. So this tells us that there is one critical number at x is equal to 1. Okay. So we'll take a look. That's our critical number, so I'm going to draw a sign line for the derivative. I'm going to put the critical numbers of the function f on here. That is, when was the derivative of the function equal to 0? That's x is equal to 1. Let's see what happens on either side of this value 1. So you could test any value on either side. So if you find f prime at 0, put 0 into here, you'll get 6, which most importantly is a positive number. So we know that any value less than 0, any value of x less than 1 will give a positive derivative. And if you put 2 into the derivative, take something on the other side of 1, the value of x, you'll get 2 minus 1 squared, which is positive. Okay. All right. So what we're seeing here is that the derivative does not actually change sign, and so I think that we don't actually have a local maximum or a minimum there. This function just keeps increasing and it never comes down. So what you think is that in this plot that it's going up and then maybe it's coming down. So if we kind of zoom in on this region, maybe if we go from like 0 to 2, right? You can see that this function kind of flattens out, but it never comes back down. So if we zoom in on 0.5 to say 1.5, right, the function just keeps going up and up. So the function never actually goes up and then comes down. Okay? So here's an example where the second derivative test, we didn't actually get the derivative to change sign, so that there is no local max or local min. Okay? So it's only when the signs change, when you go from a positive to a negative or a negative to a positive. Only in this case do you have a local maximum or a minimum.